I'm Tom from Do It Yourself Home Automation, and this is the indoor electrical portion of my apartment scale solar system. So this is a solar system I'm testing out that's built for renters or apartment dwellers who want to have a little bit of solar power on a balcony or something like that. And in another video I showed the Renogy panels that I put up on a little balcony outside of my window. They're not attached permanently to the structure at all, so it's something you can put in even if you're renting your house or an apartment. And then this is the interior portion of that system that I'm showing now. So I've got these 10-AUG cables coming down from the roof, and this is all sort of a mess at the moment because I'm still working on installing it. They go into this Renogy Adventurer charge controller, which takes in the power from the panels and regulates that to charge a battery. And this is a really nice one because it does have this display on here so you can see, versus the Wanderer, which I've shown in other videos, is the more basic controller. This one, you're able to see some stats on how your system is performing. So right now it's putting out about 4.6 amps, you could see there. You get info on total generation, and if you pair it with a Bluetooth module, you can actually pull up stats for the system in real time on your phone. So the solar panels come in here. Then I've got another set of cables coming out and going into a battery. And I've shown other videos about how to choose a battery. Importantly, this one is just a car battery. You wouldn't want to use this long term because you'd wear it down very quickly. It's not designed for a solar system where you might need to discharge it very far each day. What you want is a deep cycle battery rather than this, but this works for testing. So we have this battery coming in and then coming back out from the battery terminals here. We go into a Renogy 500 watt pure sine wave inverter, and that's going to take the 12 volt power I'm getting out of the panels and out of this battery and put it into 120 volts so that you can then just plug in any kind of household appliance and use that with the system. You could also plug in lights and that kind of thing that are designed for an RV or a car, so you're using actual 12 volt equipment, and cut out this inverter, which would probably lead to a better efficiency overall. But I want to use this to power some materials that are actually 120 volts, so I do have that inverter plugged in. And again, what I'm getting from this right now, I have 150 watts of panels on the roof, though as I'll show in another video, the way it's set up, I'm actually not using all of that capacity. So I have maybe about 120 watts of usable capacity. In nice sun right now, I'm getting about 4.7 amps out of the panels, and that's going into my batteries here, charging this up. You can get the battery voltage, it's 12.8, so it's relatively full. Again, you'd want to use a deep cycle, but this works just for testing. And then going into the inverter over here, the total cost on the system, the battery is about $120, but again, you'd want to use about a $200 battery on there for the same 120 amp hour capacity, deep cycle. This charge controller was about $80 from Renogy, and then the inverter was somewhat over $100. So, this is great for backup power in an emergency. It's great if you just want to experiment with off-grid systems. Unless you're paying a lot for electric, you're probably not going to save money on your electric, but again, just to have that backup in the event of a power outage, or if you just like to have some solar power coming into your mix. This is the system, the bottom part with the electronic components I've got going here. Once this is no longer such a rat's nest and is actually installed, I'll show a lot more about the different components of the system and give some data on how it performs over time. If you found this helpful in any way, please subscribe to my channel. Thanks so much.